We're going to rotate this region about the x-axis. Let's see if we can get a nice picture going. E to the negative x looks something like this. E to the positive x is going to look something like that. You'll notice that they both cross through the point 0, 1. And let's just say that this x value right here is the natural log of 19. Then what we're going to do is we're going to slice this region up vertically, and we're going to rotate each one of those little slices to create a thin washer. And maybe I can draw a few of these washers to give us an idea of what this volume is going to look like. It looks kind of like a slightly open bird beak to me. Anyway, you'll notice that each one of these slices has a thickness of dx, so we're going to be integrating with respect to x at some point. And we need to find the volume of each one of these little washers with a thickness of dx. Well, each washer is made up of a bigger circle with a smaller circle removed from it. So the volume of the bigger circle is going to be pi times the bigger radius squared. That's going to be pi times e to the x squared in this case, times the thickness of that washer. And the volume of the inner washer is also going to be pi r squared, except this r is going to be the smaller radius, which in this example is e to the negative x. More commonly, we would write this as... And if you look in your books, the washer method is going to look something like this. At least this version of the washer method will, where we're rotating about the x-axis. Okay, back to our problem. What we need to do is we need to add up all of the volumes of all of these washers. To do that, we integrate, and we're going to integrate from x equals 0 all the way up to x equals the natural log of 19. Okay, now this integral is going to give us our volume, so let's see if we can simplify and complete it. We used our rules for exponents here, and now we can integrate. If you're wondering what happened here, we did two small u substitutions. One u substitution was u equals 2x. The other u substitution on the second term was u equals negative 2x. For our first term, we brought down a factor of 1/2. For our second term, that brought down a factor of negative 1/2. Now we can plug in our upper and lower limits of integration and find an answer. Okay, again, we have an exponential and a logarithm, and they want to cancel each other out, but there's a 2 or a negative 2 in the way. So we have to use this trick with logarithms. And if we recall that e to the 0 is 1, the number that we get out of the lower limit of integration is just 1. Now let's see if we can simplify a little bit more. 19 to the negative 2 power can be written as 1 over 19 squared. If we do a whole bunch of simplification, we get this as our exact answer, or we get an approximate answer of approximately 563.9 cubic units. All right, let me zoom out on that so you can see all of the work. So we've done a video on the disk method and the washer method. In the next video, we're going to talk about the shell method. So I will see you there.